Okay, today we start the long process of solving basic exponential equations. An exponential equation is one where the unknown is a power. For an example, in this case right here, 32 right here. 4x is equal to 32. And I'm trying to figure out what x is. Well, I don't know. It's not 2 because 4 squared is 16. It's not 3 because 4 to the third power is 64. So I can't really guess the answer. So is there something I can do to help me get to the answer? The answer is, what you want to do is you want to check to see if the bases are similar, or can you make the bases the same. So take the number 4 for instance. If I created a factor tree for the number 4, well, 4 is equals to 2 times 2. So 4 is equals to 2 squared, correct? Similarly, if I did a factor tree for 32, 32 right here is 8 times 4. 8 is 4 times 2, that's a 2, 2, and the 4 is 2 times 2. So therefore, 32 is 2 to the 5th power. For all basic exponential equations, you will have this happening. Each of these right here have the same base. This is crucial in solving these basic exponential equations. So, what I'm going to do is, instead of writing the number 4, I'm going to write 2 squared. Instead of writing 32, I'm going to write 2 to the 5th power. So now, as this looks right here, you can see that the equation has not changed. Same. So what do I do next? There's a nice rule that says when you have a power to a power, you have to multiply. This is one of the rules that you need to write down. Put a nice little color on this right here, because this is a rule you will use over and over again. So this simplifies to 2 to the 2x is equals to 2 to the 5th. The next rule right here is actually called common sense. But it is a rule that states this right here. This is an equal sign. I am saying that the two sides are the same. Well, if the bases are the same, then the powers must be the same. See what I did right here? Since the bases are the same, then the powers are the same. This is why these right here needs to be the same. Right here. What in effect we are doing is we are simply canceling the bases. When I cancel the base right here, this leads me to a regular equation. I can divide, and so I will get that x is equals to 5 halves. And that's the solution to my first equation. Again, 2 key rules. You have to multiply when you have a power to a power. And when you have the same base on each side, you can eliminate them. You can break out, as they say, your ninja stars. Your ninja stars. Alright. Example number 2. By the way, we'll be going through several examples. You need to write all of these examples down and make sure you can do them each very well. Most people don't have that much experience in solving exponential equations. And so the more of them that you see, the better that you get at solving them. So again, I have 25 raised to the x plus 1 is equals to 125. I do my little factor tree. Well, 25 is 5 times 5. So that's 5 squared. And 125 is 25 times 5. That's 5 times 5. And so I have 5 cubed. So I go in and I do my replacements. Instead of writing 25, I write 5 squared. Instead of doing 125, I do 5 cubed. Well, when I have a power to a power, I must multiply. And so I distribute. And so I have 5 raised to the 2x plus 2 is equals to 5 to the third power. I look very carefully. I see I have the same bases. So I can eliminate them. Cancel bases. And so that leaves me with 2x plus 2 is equals to 3. And then algebra. My best friend in the whole wide world will take me home. minus 2, 2x equals 1, divide by 2, x equals 1/2. So the power that satisfies this equation right here is x equals 1/2. Alright, so that's the new rule right here that we need to pay attention right here, is that when we have a complex term right here, we need to distribute the two when we're multiplying. So, power to a power, multiply, make sure you distribute. You have the same bases, you cancel bases. Because canceling bases are always fun. Alright, let's try again. Now, example of the same type, but of a different flavor. Let's say I have 3 raised to the x squared minus 15 is equals to 9 to the x power right here. Again, now the base is the same. No, well, factor 3 for 3, there is no factor 3, it's just 3. But a factor 3 for 9, hopefully you should have already known that 9 is 3 squared, but you know, hey, that's all in good love. And so I have right here 3 raised to the x squared minus 15 is equals to 3 squared raised to the 9. Again, I'm making the basis the same. For all basic exponential equations, this will be true. Multiply these. Is equals to 3 to the 2x. I have the same base, so I can cancel them out. I can cancel the bases. And so that leaves me with x squared minus 15. That does not look like a minus sign. Minus 15 is equals to 2x. I take my 2x over and I solve. You have to remember that whenever you see a squared term right here, as an exponent right there, that's a quadratic equation. You have to use a technique to solve. The technique I'm going to use is the one called factoring. So this factors into x minus 5, x plus 3, and so I get that x is 5 and x is negative 3. Exponential functions have a domain of all real numbers, so that automatically means that these two answers are good. So those are my two answers to my equation. Notice again that solving these problems right here were exactly the same steps. Nothing special right here. Nothing to write home about. Alright, let's make this more interesting. Let's give you more information. Let's look at negative powers. When I have a number raised to a negative power, the negative power means to find the reciprocal. So, similarly, if I have a fraction, I can simplify that fraction by writing it with a negative power. See what I did right here? I did this, but in reverse, down here. So when I have a fraction, I can write it with a negative power. So again, if I have the fraction 1 over 16, this is simply 16 to the negative 1. Another power advantage of this, this reciprocal arrangement is that if I have 3/4, I can actually write the 3/4 as 4/3 raised to the negative 1 power. Because the negative 1 power right here means the reciprocal. Alright. Again, something I like to remind people of is the 0 power. And the 0 power states that if I take any number and I raise it to the 0 power, that is equals to 1. Which is interesting. But when solving basic exponential equations, and I need to get the denominator the same, if I have the number 1, I can write the number 1 as any power raised, any base raised to the 0 power. As you'll see in a little bit, this is actually quite useful sometimes, helping you to solve a problem, because you know you gotta get the bases to be the same, correct? Here I have my choice of base. So, let's look at an example right here of this right here. So let's say I have, what is this, example number 15? Don't know, we're doing so many examples today. 36 raised to the x plus 3 is equals to 1 over 216 raised to the third power. I have to ask myself, do I see any fractions? And the answer is yes. And so that means I need to write that fraction with a negative power. So you're going to write this thing as 36x plus 3 is equals to 216 raised to the negative 1, of course raised to the third power on the outside. Then, when I have a power to a power, I must multiply. I hear you saying it. Say it with me. I must multiply. And so that's 216 to the negative 3. Now that I have this right here, I ask myself, well, are the bases the same? The answer is no, they're not. So, can I make them the same? And the answer is, yes, I can. To do that right here, well, I got to do a factor tree for 36. But I'm not just going to do any factor tree. I got to get the bases the same. And so I know I'm going to have to use 6's. 6 squared is 36. And 216 is 36 times 6. And so 216 is 6 to the third power. So this 36 right here will become 6 squared. This 216 will become 6 cubed. And now I have the same base. When I have a power to a power, I must multiply. I know that's what you all said. So that's 6 to the 2x plus 6. Be careful. Distribute that 2. And then that's 6 to the negative 9th power. So now the bases are the same. So I say bye-bye base. See you later. And then algebra will take me home. Minus 6, 2x equals negative 15. Divide by 2, divide by 2. X is equals to negative 15 halves. So far so good. Well, let's try again. Let's say I have 9 raised to the x plus 1 is equals to 1 over 27. Do I have a fraction? Yes, I do. 9x plus 1 is equals to 27 to the negative 1 power. Well, 9 is equals to 3 squared. 27 is equals to 3 cubed. And so this is 3 squared raised to the x plus 1 is equals to 3 cubed raised to the negative 1 power. 3 to the 2x plus 2 equals to 3 to the negative 3. After multiplication, I say goodbye to the bases. And so I have 2x plus 2 is equal to negative 3. And then I solve. Minus 2. 2x is equal to negative 5. X equals negative 5 halves. Yet another example. Let's say I have 8 raised to the 2x plus 1 is equals to 1, and I need to solve this right here. Well, I could do a factor tree on 8, but I can't do a factor tree on 1, can I? So what am I supposed to do with this 1? Oh, and then I remember. 1 can be written as any base to the 0 power. And now, all of a sudden, my bases are the same. So this will cancel, and this will cancel. And so that leaves me with 2x plus 1 is equals to 0. Subtract the 1, 2x equals negative 1, divided by 2x equals negative 1 half. Another way to think about this problem right here is that my answer is 1. Well, the only way I can get an answer of 1 is if the power up here is 0. And so I got to figure out, well, how do I make this 0? And so I set it equal to 0 and I solve for x. That's a different way of thinking about this same problem. Again, let's give you more information. Hopefully you've noticed that's what we've been doing so far, giving you key pieces of information that will help you get to the answer. The next piece of information is something called the natural number. The natural number, or Euler's number, is denoted by the letter E. It is an irrational number like the number pi. You know, pi goes on forever. 3.14 forever. The number E is 2.71828 blah blah blah, going on forever. You can Google the letter E and you'll get, this is the second option I believe. It'll give you information about the mathematical constant E. But whenever we write E, we're writing 2.71828, just like whenever we write pi, we're writing 3.14. The number E is special in mathematics, and when you look it up, you get some information about that number E. What you will see as you practice these problems is you'll see some examples where the base is E. And that's fine, I can have a base of E. It'll get eliminated like all those other bases. So let's say I have, for example, e raised to the 2x is equals to 1 over e to the x multiplied by e to the 5th power. Well, do I have a fraction? And the answer is yes. So that means I'm going to have to make that thing a negative power. So that's e to the 2x is equals e to the x raised to the negative 1 times e to the 5. I got to multiply these things together. And so that's e to the 2x is equals e to the negative x times e to the 5. By the way, when you get good, you can actually skip from this step all the way to the third line right here. It's a fraction, it's 1 over e, it's going to be e to the negative x. But you don't have to, you can always go through those two steps. That takes us to a new rule. Well, technically it's an old rule because you actually already know this rule. When I am multiplying with the same base, I have to add the powers. Consider this. Let's say I have x to the 4th multiplied by x to the 7th. Well, this is going to be x to the 11th power. You have to add the powers together, right? Right. When you have the same base, you keep the base and you add the power. So, similarly, if I have e to the 4 times e to the 7, this is going to be e to the 11th power. Right. Quite right, Captain. Right. Quite right. And so if I have e to the negative x times e to the 5th, this is going to be e to the negative x plus 5. When you are multiplying, you add powers. And so this equation, e to the 2x is going to be e to the negative x plus 5. By the way, this is actually one of the most important rules to know. And in fact, as you go through your math career, you'll actually use this very often. But now, look, I got the same base, so I can cancel them out. Notice that I did not need to know that e was 2.718. They always end up canceling out in the end. And so therefore, this is going to be 2... Did I write the wrong equation? No, I didn't. It's going to be equals to 2x is equal to negative x plus 5. I add x to both sides. And so I get that's 3x is equals to 5, and I divide by 3. So x is equals to 5/3. Because 5/3 are better than 1. Yeah. Guess what? There's more stuff to learn. You poor peoples. But before we do that, let's try another example. One that's, again, same concept, but a different flavor. Let's say I have 2 raised to the x squared is equals to 1 over 4 to the x times 2 to the 15th power. Again, do I have a fraction? Yes, I do. So that's going to be 2 raised to the x squared is equals to 4 to the negative x multiplied by 2 to the 15th. Now, are all the bases the same? No. Can I make them the same? Yes. 4 is equals to 2 squared, and so this becomes 2 raised to the x squared is equals to 2 squared to the negative x times 2 to the 15th power. These two will multiply. Notice how all of those properties that we learned previous are still needed. That's why you need to sit down and practice enough with them so that they become familiar. Now that I have this right here, notice that I have the same base and I am multiplying. So that takes us to the addition rule. You keep the base and you add the powers. So that's 2 raised to the negative 2x plus 15. Now I have the same base on each side, so now I can cancel. And that leaves me with a quadratic equation to solve. Boy, this question is tough. I have to take the 2x over. I have to take the 15 over. And so that leaves me with x squared plus 2x minus 15 is equal to 0. I got to factor this lovely equation. X plus 5 times x minus 3. And finally, I have made it home. These are my two answers. These are the two answers you are looking for. Alright. The last concept that we have to tackle when looking at solving equations are when we have fractional powers. Fractional powers are a way of thinking about, well, let's go this way. Let's say I have x raised to the 4/3 power. This is the same as taking the cube root of x to the 4th power. When I have a radical, I can write it as a fractional power or vice versa. The 3 that I am dividing by becomes the root. The 4 becomes the power on x. Again, let me write that. Let me write another example. Let's say I have m and I'm taking the 5th root and raising it to the 3rd power. This is going to be m to the 5/3. A nice little shortcut that I like to do is I erase the radical and then divide by the power. So that means that this is wrong. So this goes the other way, 3/5. There we go. Undo. This should be 3 over 5. This is the power, the 5 is the root. This 5 ends up below the 3. Some nice examples. If I have the 7th root of y, this is equals to y to the 1/7 power, because there's a 1 power right here. The most famous example is the square root. The square root is always the 1/2 power. Again, it's the most often used. There's a hidden 2 right here, and there's a hidden 1 right here. So most people forget about those hidden numbers. But if I am taking the square root of 15, that is the same thing as 15 to the 1/2 power. Interesting, right? And so of course we're going to do an example where we have a radical. Not like we have anything else to do, right? So let's say I have 3 raised to the 4x minus 2 is equals to the 5th root of 9 squared. You always change real radicals to a fractional power. And so that's going to be 9 raised to the 2/5. Well, are the bases the same? No. But hopefully we've seen enough to know that 9 is 3 squared. I have to multiply these two. 2 times 2 over 5. I make this 2 over 1. So that's 4 over 5. So that's 3. 4x minus 2 is equal to 3 to the 4/5 power. The bases are not the same, so unceremoniously we just get rid of them. It's not like we like them or anything. And so that's 4x minus 2 is equals to 4 over 5. I have a fraction. The simplest thing to do is to get rid of it, so I multiply everything by 5. And these will cancel, so that's a 4, and that's 20x minus 10. And then the algebra will take me home. Add 10. So 20x is equals to 14 divided by 20. Oh, that looks like a W. And so x is equals to 14 over 20, which reduces to 7 over 10. That's my answer. One last example before we go. Let's say I have 25 raised to the x minus 1 is equals to the 4th root of 125. Well, there's a hidden power 1 right here, correct? So I get rid of the radicals. First thing you always want to do is get rid of the radical. 25 x minus 1 is equals to 125 raised to the 1/4 power. Remember, the 1/4 becomes the denominator when you're converting. And then, we've already seen this. 5 squared is 25. 5 cubed is 125. I multiply. 5 to the 2x minus 2 is equals to 5 to the 3/4. And of course, unceremoniously, we cancel out those bases. Say hello, base. See you next time. I have a fraction, so I multiply to get rid of that denominator. And so I have 8x minus 8 is equals to 3. Add 8. 8x is equals to 11, and so x is equals to 11 over 8. We've covered a lot of information. Take your time to go through all of these and practice. Change the basis. Instead of using the 25 and the 25 right here, use 4 and 8. We know both of these break down to 2 in the 2 squared and 2 cubed. Use numbers with like bases and then rework the problem. The more practice you get, the better off you will be.